Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 2 to the power of m minus 2 to the power of n is equal to 2016. Now, by knowing this, we could actually decipher a couple things. Because this is positive, 2016 is positive, we know that m has to be greater than n. Because if m was negative, then this would actually be negative. And if n was greater than m, this would actually be negative 2016. So by knowing this, we could just say that m is equal to n plus k. K being a constant. So now if I subtract k on both sides, I get m minus k is equal to n. So now I'm actually going to replace m with, I'm going to replace m with n plus k. So now we have 2 to the power of n plus k minus 2 to the power of n is equal to 2016. Now this can also be written as 2 to the power of n times 2 to the power of k minus 2 to the power of n is equal to 2016. And now if I factored out 2 to the power of n from this, I would get 2 to the power of n times 2 to the power of k minus 1 is equal to 2016. So now 2016, well, this is actually equal to 32 times 63. So now we have 2 to the power of n times 2 to the power of k minus 1 is equal to 32 times 63. And now 2 to the power of n, this is actually going to be an even number because 2 to the power of anything is going to be even. And 2 to the power of n minus 2 to the power of k minus 1, well, that's going to be odd. Now 32, well, that's an even number, so I'm going to write e for even, and 63 is odd. So meaning we could just say that 2 to the power of n is equal to 32, and 2 to the power of k minus 1 is equal to 63. So if 2 to the power of n is equal to 32, then n is equal to 5, because 2 to the power of 5 is equal to 32. And we have 2 to the power of k minus 1 equals 63. If we add 1 on both sides, we get 2 to the power of k is equal to 64. Meaning k is equal to 6. So now if n is 5 and k is 6, well, we could simply plug these into this. M is equal to n plus k, and n plus k is 5 plus 6, which is 11. So m equal to 11. So now these three are our values. Guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 3 to the power of x minus 1 is equal to 2 to the power of x. Now, if we have something in the form a to the power of m plus n, this can actually be written as a to the power of m times a to the power of n. So as you can see here, we have 3 to the power of x minus 1. This can be written as 3 to the power of x times 3 to the power of negative 1. And this is equal to 2 to the power of x. Now I'm actually going to divide by 2 to the power of x on both sides. So now we have 3 to the power of x. And I'm actually going to move the 3 to the power of negative 1 to the denominator, and now it's going to be 3 to the power of positive 1. So now we have 3 to the power of positive 1 times 2 to the power of x. This is equal to 1. Now I'm actually going to multiply both sides by 3. So now these two cancel out, and you're left with 3 to the power of x over 2 to the power of x is equal to 3. So now this can be written as 3 over 2 to the power of x is equal to 3. Now if I take the ln of both sides, you get this can actually be moved to the front of the ln because this is an important property of logarithms. So now we have x ln 3 over 2 is equal to ln 3. And now I'm actually going to divide both sides by ln 3 over 2 so I can isolate x. So now these two cancel out, and we are left with x is equal to ln 3 over ln 3 over 2. Now, although this is a fine answer, this can actually be simplified because if we have something in the form ln a over b, this is actually equal to ln a minus ln b. So ln 3 over 2, this would equal ln 3 over ln 3 minus ln 2. So this is our answer.